Alrighty, this is your one for your lab. This is your STAAR foldable for your lab. Okay, we have done so much of this and I've been so proud of you. We've gotten through all the beginning of the year stuff, scientific notation, proportional relationships, functions, linear relationships, being able to identify linear relationships using slope man, finding slope using rise over run, identifying linear equations in words and in tables, finding constant of proportionality or slope in word form, graph form, and table form. Reviewing our favorite equation in 8th grade. Going over mean absolute deviation, remembering what mean is, which is average. We have done solving two-step equations. You should have this part done. This we're going to be doing Thursday, as you can see. And so we should have done this in class. We have done all of square roots and Pythagorean theorem. We've done all our angle relationships with the geometry part. And so now let's get into plane geometry. Things on a coordinate plane. Not like plain Jane, like boring. No, plane geometry. So we're going to be talking about translations, rotations, and reflections, and dilations. Alright, so this part right here, I want you to be able to identify all the parts. The big ones being the x-axis, the y-axis, origin, where everything begins. Be able to go through your coordinates, 1, 2, 3, 4. Remember, a C makes them. Remember, horizontal is this way, vertical is this way. Your x and y coordinate. When you have a coordinate, x is first, then y. How to locate it. So this is your x coordinate, this is your y coordinate. Okay. So, I want you to be able to label all these parts on here. I'm not going to do it for you. This is how I'm going to check you. Now, this right here, I'm going to go through step by step with you. Translations. Remember, it is simply sliding. Notice it says translation slide. It's sliding the figure. It doesn't get bigger or smaller. It stays the same size. It's just moved. And we have to figure out how much it's moved and how and why. And you're going to do it by counting your coordinates. So, we first have to find which one is the original figure and which one's the new figure. Original always has just a normal letter. The prime, see it little small, that's going to be your new figure, okay? Alright, so list all the coordinates of the first one. So it's going to be -2 and +6. So this is -2, +6. B is 1, 6. C is 2, 6. Oh, no, 2, 3. Excuse me. 2, 3. And D is -2, 3. Okay. Now, we're having to figure out how much it moves. So I'm going to move down here to this. How does it change? Alright, so if I find my new coordinates, I'm going to have to figure out how much there is between them. So let me find my new coordinates. So this is going to be 3, -2. B is 6, -2. C is 7, -5, and D is 3, -5. Okay, So how do we figure out the rule? How much did it change? Yes, you can simply count. This is an easy one. You can just count down. Or the more mathematic way is to subtract them. Alright, so I can subtract the new from the old. So it would be, in this case, 3 minus -2. My answer is 5. So 1, 2. 1, 2, 3, 4, 5. So my x coordinate changed 5. Now, did it go positive or negative? If it moves this way, remember that to the left or to the right is positive, and this is the x coordinate, and then left is negative. Okay, so it moved this way to get from here to here, so it is a positive 5, and we know that just from our calculation. Look, it's a positive 5, but just in case you didn't know. Alright, comma. Now let's find our y. Remember, y, if it goes up, it is positive. If it goes down, it is negative. Okay? And if you need a little help, these are pluses. This is negative. Okay? And you can tell it goes down. So what are you going to have to do? You're going to take a y coordinate and you're going to the new over the old. So you go -2 minus 6. And you get -8. So y changed -8. And that's the rule. That's how it changed. I can do it on any one of these. Let's try it with this. 3. If I go, well, let's do this one. If I do 7 minus 2, I should get 5. That's my x change because I did it with my x. Now with my y, it's -5 minus 3. Get -8. That's my change. And sure enough, that's where my new points are. So remember, it is new or image minus the old one. Okay? That's how you find the rule. Okay, now let's talk about rotations. Rotations. Here's our rotation. It says, what quadrant is triangle ABC in? ABC, it's right here, so it's in quadrant 1. This is quadrant 2, quadrant 3, quadrant 4. Okay? So, ABC, and this is the image ABC, so what quadrant is ABC located in? Quadrant 1. Okay? What quadrant is ABC prime located in? Quadrant 4. Okay? How many degrees did it rotate? And which way? Clockwise or counterclockwise? I'm going to kind of both answer. So it starts here, and it has to go all the way around to that way. Counterclockwise. So how many degrees? This is, right here would have been 90, 180, 270. So if it's counterclockwise, it's 270 degrees. If I went clockwise, which is this way, it went 90 degrees. So clockwise, it's 90 degrees. So what direction did it rotate? Well, it depends. I would say it did clockwise 90 degrees. Now, remember our rules. The weird thing about this one is you've got to remember all the little rules that there are. So, give yourself a moment to go back into your journal, and let me find it. And memorize this, okay? This little rule right here. 90 degrees, the coordinates switch, one goes negative. 80-80, they both go negative. So, memorize this right here. If you would like, I can even quickly draw it on here. You need to go A, 90 clockwise, 270 counterclockwise. It changes. The Y goes in front, the X changes to a negative. Alright, if it is 180 degrees, either clockwise or counterclockwise, it just, both coordinates go negative or opposite, remember. And then 270 clockwise or 90 degrees counterclockwise, the Y goes opposite and the X, but look, they flipped around again. And then 360, everything's back to normal. It's in the exact same place you left it. Alright, memorize this, guys. Alright, now let's talk about reflections. Alright, let's first find your points. This is the original, this is the new one. So A is at -6, 2. B is at 5, -6. Or, excuse me, -5, 6. C is at -3, 7. D is at -2, -2. Or, excuse me, -2, +2. Alright. Now, in 8th grade, we're only going across different axes, okay? We're only going across the X or Y axis. So, let's find our new points for D. D is 2, 2. A is 6, 2. B is 5, 6. And C is 3, 7. So, ask yourself, what happened? When I look at these 2 points, all that happened is my X went opposite. So, remember, if we go back to our notes, remember when you go across the X axis, the Y turns opposite. When you go across the Y axis, the X goes opposite. And if you go over both of them, they both change. So, in this case, the X is what went change, so we flipped over the Y axis. And that you can see in the picture. This is the Y axis, so that's what it reflected over. And you can see that. So what happened? It reflected over Y axis. The rule, though, was the X went opposite and the Y stayed exactly the same. That's what rule occurred. Whoops, you can't see my writing. Sorry, guys. Alright. So we got all that information down. We've gone through all of the kind of transformations that the shape stays the same. Notice, this is the same size as this one. This is the same size as this one. It's just kind of changed which direction it's pointing. This one is the same size as this one. And again, it's just changed which way it's pointing. But they're all the same size after the translation. After the move, it's the exact same size. That is not going to be true with a dilation. Dilation, it is either a reduction, which is gets smaller, or an enlargement. So this one is not going to stay the same size. It's going to get big or smaller. And the angles, remember, are going to stay stay the exact same, but the sides go proportional. All right. So let's start with realizing that this right here is my original, this is my new one. So it has gotten bigger. It's an enlargement. So find your points. Start with J. J is -2 to -2. K is -2, +2. L is 0, 2. M is 1, 0. And N is 0, -2. Okay. Now let's do it for my larger figure. Start with J is 6, -6. K is -6, +6. L is 0, 6. M is 0, 3. Oh, 3, 0. Sorry. And is 0, -6. All right. So what algebraic rule describes the dilation? So how did a 2 become a 6? So what two numbers, how did that get bigger? What is the scale factor? All right, and we know it's going to have to be a positive scale factor, and we remember that when we deal with dilation, it's always multiplication. Okay, so it's always multiplication. So how did 2 times what equal 6? Well, if you're saying 3, you're right. So it was 3 times x and 3 times the y. So the scale factor is 3. This large one is 3 times the size of this small one. So the scale factor is 3. We had to multiply that by each one of the coordinates to get it. Okay, now let's talk about this one. Alright, this is the original, this is the new one. Notice it's getting smaller. So I know my scale factor is going to be less than 1. So scale factor for enlargements. Scale factor is greater than 1 or larger than 1. For reductions, the scale factor is less than 1. Okay? If it happens to have a dilation and it stays the exact same place, it's 1. So, all right. So let's start with A is 3, 3. B is 6, 0. C is 6, 6. All right. A is 1, 1. B is 2, 0. And this is 2, 2. Okay. So, how did 3 become a 1? Well, you're going to say it got smaller, so it divided. But go back to what we talked about. Remember, it is new over old. So the new is 1, the old is 3. So wait, aha, there's my scale factor. It's 1/3. So I did 1/3 x, 1/3 y, and that is my rule. I can do the same thing, so my scale factor is 1/3. I can do the same thing here. It would have worked just the same. New over old, if I pick my j's, I'll just start here. -2, this is my old. Let me do new. Sorry, I'm getting ahead of myself. -6 over -2. If I would have put that in my calculator, sorry, I skipped this step. It would have been alpha stat plot -6 over -2, and you get 3, which we said was the scale factor. So that is how you find the scale factor, is the new over old. Okay? And remember, it's always multiplication. It's easy to tell the difference between all the different transformations because translations always have the add and subtraction. Rotations, it's one of the coordinates has gone positive or negative or possibly switched places. This one has gone positive or negative. These are sometimes hard to tell apart, but they usually are accompanied with a picture, and then you can clearly see. And then dilations always have multiplication. See, even if it's a fraction, it is multiplication. Okay, so this is what you need to be doing. This is kind of a long video, but I do want you to go through on your own, label these parts. I'm going to check it to see if you've labeled all these parts. You don't have to really label horizontal and vertical. That's kind of impossible to label. But everything else, you should be able to label on your coordinate plane. All right, bye guys.